You know, you guys were barely paying attention earlier, so... Just kidding.
What else? You should have at least 3 more bear puns.
Yeah. Bear with me. Bear with me here. I got to think of another one. Because, you know, bears are the #1 threat to America, right? There's a lot of us out there. Our next speaker, Rebecca Murphy. I actually heard her speak at my first JSConf, the one in Portland, and I took away some really great information from that talk about frameworks and JavaScript. So let's hear what she has to say about deploying client-side websites, 1,000 or so at a time.
All right, so I have my box of tissues, and I apologize. It's like a necessary accessory for me giving any talk whatsoever. I was just dying in there, but it seems like I'm not going to die, so thank you to Tara for the antihistamines. Before I get started, though, I wanted to, we're in the home stretch. We've had lunch. My job is to keep you awake for the rest of the speakers for the rest of the day. If you haven't been to a few conferences, I've been to a few conferences, you might not know that this thing that you've gotten to be a part of, I'm getting goosebumps even saying this, like this thing that you've gotten to be a part of for the last few days, or even if you've just been here today, it is extraordinary. This is not normal. This is amazing. I've made new friends. I've seen audience members who were moved to tears. And I felt really, truly part of a community that is doing great things. So I just wanted to say thank you to Tracy, thank you to Carter, thank you to Marcy today, and to the entire staff, and to all of you for letting me be a part of this. So, high five to Cascadia. I also want to say thank you to Jeff Lembeck, who talked 2 days ago. Was that 2 days ago? Wow. He talked 2 days ago about he kind of laid the groundwork for this talk, basically. So I want to appreciate that. He, if you missed it, he talked about designing tools. And how, if you aren't careful, you can design monolithic tools that are difficult to work with, reason about, and change. And that wasn't supposed to happen yet. Go back. There we go. Not that far back. Cool. Wow. All right, this is the slide we're supposed to be on right now. This is my Wiimote that's supposed to be telling the slides where to be. So I want to talk today about how we've been rethinking deploying client-side apps at Bazaar Voice. So a client-side app is, we often think of them in terms of single-page applications. So it's some HTMLs, or some templates, some JavaScript, some CSS, that makes there be a web experience. And that may be paired with some server technology. It may not be paired with some server technology. In our case at Bazaar Voice, we have an app that is entirely a client-side app. It reaches out to an API, but there's no server behind it. So I'm going to talk about it, and I want to also make a disclaimer here before I get too far. This is not a how-to talk. This is not a talk where you should go home and do exactly what I'm talking about. For one, what I'm talking about isn't done yet, and for two, this is really a talk more about how we thought about a problem and how we revisited the tools and technology that we were using in order to solve that problem. I'm hoping at some point we can open up the code so that other people can see it, but it's probably not code that you want to go put in your own production world, especially if you don't have, if you aren't working kind of at the scale that we're working with at Bazaar Voice. So Bazaar Voice does a lot of things, but the short version is we do ratings and reviews software for brands and retailers. So if you're on a product page on a retailer, I don't know which ones I'm allowed to say their name up here, so I'm not going to say any of them. Basically, if you're on a product page for a retailer and that retailer isn't Amazon.com, there's a pretty good chance that you're seeing software that's created by Bazaar Voice for displaying and collecting ratings and reviews. I worked for about 1.5 years on the third-party JavaScript application that actually displays and collects ratings and reviews on our customers' websites. It's basically a single-page app that runs inside of other people's pages. That's OPP. I like it. It's cooler than 3PJS. So it's a single page app that runs inside of other people's pages. And the way it works is it's a common code base for all of our customers. And every customer gets a build for every supported locale for every site that that customer has. So if you think about a customer such as, I'm just going to say it, don't tell. If you think about a customer like Gap, they actually have several different brands. They own Old Navy and Piper Lemon and something in the UK, and so they have several different sites, even though it's one customer. And you can imagine that each of those sites has to support multiple different locales. Even if it's just ENUS and ENGB, we have to make sure that we spell color right, like with a U or whatever. And you Canadians understand that, I'm sure. I still don't get it. So for a customer who has, we have other customers who have like 10 sites and 130 locales because they're truly global. And so if you do the math, you can imagine that we're doing a build of their JavaScript and CSS for every site, for every locale, every time they make a substantial configuration change. And so that could be changing some text, or that could be changing the color of a button or whatever. So the math of that adds up to, we can totally be doing 1,000 or more builds in a day for our customers. And we can absolutely be doing 1,000 or more builds a day if we need to roll out a bug fix to everyone who has deployed since we last, who has deployed since we shipped whatever the bug was. So the way that this build process has a lot of steps. If you are putting any JavaScript code in production, you probably have a process that's a lot like this, or has some aspects of this. It doesn't matter what all the steps are. Eventually I got tired of listing them and just said probably some stuff that I forgot. But there's probably in the ballpark of 15 to 20 steps, distinct steps that we can talk about, like things that happen in the process of taking a customer's intent to deploy and turning that into an actual deployment of the application. So currently, the way this works is we have servers that sit and wait to be told that they need to do a build. Whether they're doing builds or not, they're sitting there thinking about maybe we might want them to do a build soon, and so we're paying for that. And when they get a build message, they literally run 4 grunt tasks. So not the 15 grunt tasks, 4 of them. This is when your heart just dies when you're reading our build code and you find this in it, where it's literally shelling out to execute 4 grunt tasks, populated with some arguments that you passed in somewhere. It's sad, and this is why I have bourbon on my desk. So these 4 grunt tasks they actually perform those 15 plus steps that I just showed you, and this is really terrible. It's terrible. It's not just an excuse to drink. It's actually terrible, and it's terrible for a lot of different reasons. The biggest reason is that on that slide before, there weren't 4 things. There were 15 things. And so we aren't treating these steps as distinct and unique and things that have input and produce output. We're just so there's this bunch of stuff that we do, and then there's other bunch of stuff we do, and then there's other bunch of stuff we do, and then we do another bunch of stuff. And they're a collection of smaller steps, but they're written in a way that you can't reason about them as smaller steps. You can't reason about them, like I said, in terms of their input and their output. It means that it's really difficult. When something goes wrong, it's really difficult to figure out what has gone wrong or where it went wrong. And they're written in such a way that they're deeply entangled with each other, and so they have side effects that you don't necessarily expect them to have. They all have to run on the same machine because they're all writing to the same file system and reading from the same file system. And what the upshot of all of this is that we have a team of people who feel utterly powerless to do anything with the system except not touch it. That's kind of the state of the world right now. So a while back, we got to thinking about what is a build? What is this thing that we're doing? Fundamentally, any build is a set of steps. Those steps might be serial. Those steps might be parallel. But ultimately, those steps or that series of steps or that set of steps, it's triggered by some initial input. It produces some final output. And in any reasonably complex system, any slightly complex system, there's pretty much always a chance for some kind of failure to happen along the way. Our build has to download some images that are on a server somewhere. Something like, this is the internet, things go wrong. And so there's always the opportunity for something to go wrong, and our build has to be prepared for that. So a step, what's a step? A step is a unit of work. It might be asynchronous. It's probably asynchronous because it wouldn't be fun if it wasn't. It probably requires some input, but not necessarily. It probably depends on some service. Not necessarily, but it might. Some third-party service. And ideally, it is producing some output. Otherwise, we probably wouldn't be doing it in the first place. So you can think of different build processes as looking, these are kind of 3 different things that they could look like. A really simple one that's successful is just a series of steps, no big deal. A more complicated one might have multiple steps that can be performed in parallel. And then the sad face one is when a step has to be retried several times before it actually, before it completes. Or maybe it doesn't complete and we have to abandon the workflow. If we think about this, and think about like how we could represent kind of these different scenarios in code, we come up with something like this. This is a set of steps to be run in series. You run step 1, you run step 2, you run step 3, and then you're done. So we can represent it that way. Each step has a name, which doesn't matter. It also has an activity type. This allows us to have like multiple, like the same kind of activity could run multiple times in different parts of the workflow if we need to. And it also has information about the kind of input that the step is going to require in order to be successful, where it's going to get its input from. So we could think about representing this notion of doing a set of steps like this. And it's not too hard of a logical leap. I don't have it here, but it's not too hard of a logical leap to think about how we could, do some nesting so that we could actually achieve parallel steps here as well. A step in this list could actually be a collection of sub-steps that had to run. And what's a step? Well, a step might look like this. This is a step with some commenty hand waving that sends an email using the AWS simple email service. It's just a node module. It exports a function, and that function accepts an input argument and returns a promise. Here we're using the Q library, but what really matters is that we're returning a promise from this method. So that's where we kind of were. We had figured out, like, this is how we actually want to represent these. We want to break this down into really small steps with clear inputs, clear outputs, promise-driven, having these recipes for how the workflow is going to work. Had lots of meetings, lots of whiteboards, lots of markers, and we had worked through, like, kind of what the interface would be for this. And understanding that all of this was grunt-powered up until now, grunt, which is really not good at passing data in between things and really has no notion of retries or anything like that. So we had like this vision of where we wanted to be. And we had talked through this elaborate system of SQs in Amazon Web Services and like all the different EC2 instances that we were going to have running in order to make it all work. And we had a plan, but I was like really dreading actually having to do it. It seemed like this thing that we could represent so neatly in that config object, and these steps that we could represent and encapsulate so neatly as just a function that took some input and returned a promise. Actually building the system to orchestrate all of that was going to be hard. So around this time, I went out to lunch with my friend Joe, who's a Java developer at Bizarre Voice. And he's pretty senior. These aren't like literally the tacos I ate. This is just a picture from the internet, but they're probably literally the tacos I ate. That's a shrimp taco in the foreground and a trailer park trashy in the background. If you ever go to Torchy's and need to know what to order. So I was telling about my project and like this plan that we had and describing the configurability of it all. And he was like, dude, there's this thing called Swift. And I'm like, that sounds terrible. And he's like, no, not that Swift. So Swift, Yay, my joke slide worked. Swift in Amazon Web Services land is Amazon's simple workflow. Of course, workflow is one word, but they're using 2 letters to abbreviate it. I don't know. So it's simple workflow. And you heard me say just a second ago the word orchestrate. That was a slip. I shouldn't have said that yet because I have this slide which says, like, it turns out this whole concept there's a name for it, and you can look it up on Wikipedia. It's called orchestration. And if you've been in the enterprise and, like, written some Java, you probably already knew this, like Joe did. And it turns the fundamental concept of this elaborate system that we were planning into this, like, super simple thing. And it turns out that Amazon has already, and this is not an Amazon plug, I'm sorry, like, you can do this with Node libraries and stuff, but, like, Amazon has actually, like, wrapped this all up into just total magic. And this is what Swift looks like. So you tell Swift, this is a workflow for, like, buying something. So you tell Swift that you want to start a workflow, and you have 2 things that are running. You have a decider, which is just such a cool name for a thing. And that decider is constantly saying, hey, Swift, you got any decisions to make? Any decisions I need to make? And then once the workflow is started, Swift is like, why, yes, I do have a decision for you to make. And so Swift sends a message, like, it provides a message to the decider saying, like, I got this message. We haven't done anything yet. Tell me what to do. And the decider comes back and says, well, you haven't done anything yet, so why don't you do step 1? It doesn't say step 1. It just says, why don't you do this and then get back to me. So you also are maintaining 1 or more activity workers that are also saying, hey, Swift, you got anything for me? You got anything for me? You got anything for me? And then when they get something that they need to do, then the activity worker goes off and does the work and then says, hey, Swift, I'm done, and here's the output from my task. So if you look at this you can kind of see the illustration of a simple purchase going through the Swift system. And I'm leaving a lot out. I'm leaving out all kinds of things, but this is the fundamental concept of how simple workflow works. You have a decider, you have an activity worker, and they are just constantly talking to Swift up at the top. So Joe, the Java developer, says, the one thing about simple workflow is it can be really hard to reason about because things happen out of order. And I'm like, dude, we got this. We know. We're really good at that. So out of this came this thing that we called Pontiac. We called it Pontiac because the system that it was going to be building is called Firebird, and we like puns. And so it's a system that lets you describe a workflow, much like the configuration that I showed you a few slides ago, and then it executes that workflow for you using Swift. So it, like, creates the decider that knows how to make decisions about what to do next for you. You don't have to write the decider. It just creates a decider for you. You don't have to create the activity worker. It creates the activity workers for you. They know what to do. And then it handles kind of one of the interesting things that it has to handle is how because you can have n activity workers, file system isn't really your friend anymore. And so it also makes it so that the individual activity outputs can get passed to the next activity in a friendly way. So it's a system that lets you describe arbitrary workflows, arbitrary builds via configuration, and then to define the individual steps as those really simple modules that receive input and return a promise. We tried this out using a kind of a subset of our build. It's a subset that we called Chopper. And it has a very simple purpose, which is to receive a build message, look up how many locales do I need to build this for, and actually create new messages, one for each locale. This sounds really simple. It is incredibly simple, and thus does it defy logic that the current implementation of this in the old system was like 600 lines of code. So yeah, it's an incredibly trivial thing, but we thought it was a pretty good way to look at, to just kind of like take this system for a test drive. So if you remember the diagram from a few slides ago with bouncing back and forth and bouncing back and forth, this is what that diagram would look like for what Chopper is. Pontiac gets a build message from SQS, says, hey, Swift, please get started on this. Decider finds out that there's something for it to decide. It makes a decision, and it says, you should run the get locales step. Get locales says, I'm done, and that bounces back and forth and back and forth and back and forth until finally we're done. Swift says, I've completed this workflow, and Pontiac is able to say, we're done. So we can describe that workflow a lot like the workflow that I showed you a couple minutes ago. This is the chopper workflow. It has 3 steps. A couple things that are neat about this that weren't in there before. We've actually moved the concept of retries out into the configuration. It's out of this. The step has no knowledge of needing to retry. This is not a true thing in grunt land, right? Like if you need to be retrying something in grunt, it's up to you to write that logic within the step, and it's like pretty not cool to write that in a way that doesn't block, turns out. And so, we're able to say, you should retry this one time if it fails, because this is a thing that depends on an external service. We're able to say that you should consider this failed if you haven't if it hasn't succeeded within 10 seconds, rather. And we're able to express all of that at the configuration level and keep our steps really incredibly simple. So here's that get deployment, or get locales is what this slide should say, sorry. And so if we look at the code for this step, there's it's not even slightly interesting. It uses a service to go out and get the information that we need. It's called a deployment document. Read the locales from that deployment document, and then just resolve a promise or resolve a deferred with a list of locales. And its job is done. It has no idea what's going to happen with that list of locales. This is an incredibly testable module, obviously, because it's that's the whole thing, all 15 lines. And the really cool thing is that a step author doesn't have to think about that whole system that is making this work. They're able to focus on the step itself and what that step itself needs to do. They don't have to think about retries. They don't have to think about timeouts. They don't have to think about anything. It's just this very simple, go get this resource, and once you get it, resolve a deferred, and that's it. So there are some sad face things about this. I don't know how well you can see the 2 sad faces up at the top, but the first 2 things here are sad faces. One of the sad faces is that the size of the output of a step is pretty constrained. Steps can only output a string, and the size of that string is not very large. So if, say, one of the steps is to do a build of all of our JavaScript, we can't have that build itself be the output of the step. But we can have the output of the step be a string that is an S3 URL that points to where we actually put the resources that we built. So that's one of the bummers of doing this in a distributed way, where your activity workers could be running on multiple machines. You can't use the file system anymore, but this turns out to be a pretty straightforward thing to get around. We have to store large or binary data somewhere else. So we can't rely on the file system. It's not a bummer even. It's just you kind of have to change how you think if you've been thinking in grunt land, where this whole process is running on a machine. This whole process is not running on a machine. What that means is that there's actually a possibility where, at midnight, we don't need to have these instances on and all waiting for a build message. We could have a very lightweight process that spun up the instances when a new workflow arrives, a new workflow request arrives. And there's lots and lots of things you could do. You could even get to where you're using AWS's Lambda, which is pretty cool, to actually execute the individual activities. So it's nice. It's a bummer that you don't have the file system, but on the other hand, you have a lot more flexibility if you take the file system out of the picture. The cool things is everything else. Retries and concurrency are first class, and you don't have to think about that in the steps themselves. And if in one workflow definition you want a step to have 10 seconds, and in another workflow definition you want the step to have 20 seconds before it's considered failed, cool, that's fine. So you could do different things in different environments where maybe the QA environment just has slower speeds and you need to have a little bit more tolerance. But in the production environment, you are a little bit tighter about that. The clear contract between the steps, and I'm like giddy about this. The clear contract between the steps and the incredible encapsulation of the steps is just huge. And even if you do grunt right, I think these are things that are really hard to achieve. Another thing is that the framework itself abstracts the kind of known complexities. Now, this is definitely, we had to build it using grunt to understand everything that was bad about that. But once we understood what was bad about it, that retries were hard, that encapsulation was hard, that writing constantly the file system was hard, we were able to say, all right, let's get that out of the hands of the individual step authors so that the step authors can just focus on what the step is. And that brings me to the last point. Like, adding a step is exactly as hard as writing the step and no harder. And so if it's a complicated thing that you need to do, yeah, that's going to be complicated. But if you're just sending an email, like, that's not even interesting. And we can actually share, like, once we've written the send an email step, we can share that across multiple build processes. We're no longer writing the deployment process for Firebird. We're writing the steps that can be used across BazaarBoys. The reality check is none of this is actually in production yet. Turns out that rewriting a mission-critical build system that isn't visibly broken is like not a thing that products like, cool, go do that. We are planning on piloting this. Since we started working on this, we've kind of shifted, instead of thinking about trying to rewrite an existing build system, instead trying to pilot this with some teams whose build systems are really not automated sufficiently at all. It's not just they're bad, it's that they don't exist, and trying to pilot it with them and then move on to maybe out of that we're able to provide some benefits to the team that this was intended for. And the last thing that I would say is that all tools are easy to abuse. I kind of talk about grunt as like the new jQuery. It's not really the new jQuery, but it's a little old now. But you can do wonderful things with jQuery. You can do wonderful things with grunt, but it's really easy to abuse them. And it's just another case of like choosing the right tool for the job and understanding the problem that you're trying to solve before you throw technology at solving it. And the other kind of big lesson is that smart people have probably already solved at least part of your problem. I am so relieved that I talked to my coworker Joe about this, even though I'm like, he's a Java developer. What does he know about deploying client-side applications? I'd still be working on this and definitely not talking to you today if I hadn't had that conversation with him. So, life lessons. That's my talk. I am Rebecca Murphy. I also have a podcast that's like occasional when I feel like it, but you might want to listen to it if you find this sort of stuff interesting. So that's TTL Podcast. And you can find me there. And I don't know what I did. Thank you.